Okay, we're back here with this sphere. We've done a couple of things here. We figured out P in terms of, first we figured out AC. In terms of T and 30, we went T, take away 30, that's AC. Then we did Pythagoras, T minus 30 squared plus P squared equals 30 times 30 equals 900. We did all this stuff on it, and we got P squared in terms of T, and then we substituted that in and got a formula for volume. Now let's look what the next question is. Calculate the value of T that's going to make the cone a maximum. That's the volume of the value of T that will make a maximum. Well, maximum's all you just take the formula for volume, you take the derivative, and maximums and minimums happen when it equals 0. So that's all we do. We take the formula for volume and we do the derivative. 2 times 20 is 40, bring it down 1. 3 times a third is 1, bring it down 1. There it is, the formula for volume, the derivative of the formula for volume, right there. Now we want to make it maximum, we just let it equal 0. Oh, there we go. Then we factor T out of it, and we get one answer. Hey, T equals 0. We can also divide by pi here, it doesn't really matter. And the thing that's going to make this 0 is T equals 40. You see, 40 minus 40 pi. So 40 minus 40, T must be 40 centimeters. That's what's going to make the volume of that cone maximum. Now the last question says, what percentage of the sphere was used to make the cone? Well, the percentage of the sphere that was used to make the cone. Well, we'd need the volume of the cone. If we were going to do that, how much of the cone makes up the whole sphere? Well, we'd need the volume of the cone, and we'd have to divide by the volume of the sphere. But we know what T has to be. T has to be 40. So let's see what they did in the memo. We're going to have to make a fraction, the volume of the cone over the volume of the sphere, somehow to get the percentage. Let's take a look what it looks like in the memo. Well, here it is. Here's the volume of the cone, and we put in 40. 40 for T, because if you look back in here, that T, oh, that's the height, isn't it? That's the height. Yeah, okay. Anyways, they put in 40 for T. Oops, sorry. Let's go back and take a look. Here we got it now again. We make that 40. There's the volume of the cone. But we know the sphere's got a radius of 30. But the cone, that T is the height, right? So there it is, gone in there. T, that's it. 40 cubed. We just put it in the formula, put it in our calculator, and we get 10,666 and 2/3 pi. And then the volume of the sphere, we know the radius of the sphere is 30. So there's the radius of the sphere. It's 36,000 pi. Well, we just make a fraction. 10,666 over 36,000. We get 0.2962 on our calculator. That's 29.63%, rounded off to the nearest. Okay, now does that make sense looking back in the picture here? Oh yeah, it does. Okay, T, that does make sense. The volume of the cone, I think that does make sense. The height T is machined out. It should be 40. I think that makes sense. That should be 40. Yeah. Oh, there it is, T squared. We just used the formula and T was 40, so we put it back in there. So it all does. It makes sense to me now. Okay, that's the volume of the cone divided by the volume of the sphere. Okay, that's it. All done.